Okay, optical fibers, built-in lenses, and maybe some surface areas. You can see this. So this is one example I'm showing you. This is a photodiode. What we can find on this surface in the inner side, there is a glass top here, right? Glass top here. Inside that uh, there is a solar chip or solar cell. A very small, tiny solar cell is there. Okay, which is a sensor, right? Or optical filter. Then what this solar cell is going to do? So whenever a photon, a light signal fall upon this cell, then that is going to emit the electrons. So because of that emission, the electric current is going to be produced. So that this photodiode is going to convert a light signal into electrical current. A very small amount of electric current it is going to produce. Okay, and that ray, UV rays or X rays, it is capable of absorbing UV rays or X rays also. So it is packaged with a window. See, this is a window or a glass top that is connected to the to allow light to be passed or to reach the surface, the solar surface. Okay, so how it is going to be operated? First of all, this photodiode always operates in a reverse junction, reverse bias. So whenever a light falls upon this photodiode, it is going to generate a reverse current. The current which is flowing through this is going to be a reverse direction. How it is going to generate? Now see here, whenever a sufficient energy, photon energy or light energy falls upon this diode, then the surface is there, no? So on that surface, that light is going to create electron hole pairs. It is going to create electron hole pair. So this mechanism is called as photoelectric effect, inner photoelectric effect. So if the absorption occurs in the junction depletion layer or one of the diffusion length away from it, then what could happen? These carriers are swept from the junction. That is, they are going out from the junction. So going out from the junction is nothing but the holes are moving towards the anode and the electrons are moving towards the cathode in a reverse direction. They are not going into the same linear line. Their direction is going to be opposite direction. So that is why this diode is going to generate a reverse current, and that too depending upon the lux, or we call it as a illuminance. Illuminance is the intensity of the light. Okay, so based upon that intensity of the light, the current is going to be produced. How much the current is going to be produced, that is shown in this diagram, in the characteristics of this photodiode. So what actually happening here, there is a small configuration of this diode with the battery reference voltage here. The current is flowing in this direction, in the reverse direction. Now here what is happening is the reference voltage is going into the negative, -1, -2, -3, -4, -5, and the current also increasing in the stepwise -100, -200, -300, -400 microamps. minus, that is reverse current in a microamperes. So this is where the illuminance is with the thousands multiplication, then what we are getting, the output of 300 microamperes. So the current of 300 microamperes is going to be generated when the illuminance is at the rate of 2000, at the rate of 2000. Okay, you can see it here. Illuminance is nothing but the light intensity, the energy of that light. How much the intensity of that light is going to be increased, that much the current is going to also be increased. Okay, but that conducts. So whenever a photon falls upon this diode, the holes are moving towards the anode, and electrons are moving towards the cathode, which is a reverse direction. That is why it is going to generate a reverse current. Okay, I will provide this. I think, okay, I will provide this notes for you in the group. Is it okay? Shall I go ahead?
Yes, sir. Yes, sir.
Yes, sir.
Already in the in the previous class, we have discussed this. I'm just repeating it. A simple LED light emitting diode, how it is going to emit the lights now. So what will happen? LED is also a semiconductor light source, semiconductor diode, where it is a source. It acts as a source for emitting light signal. A light is nothing, photons. So when current flows through it, when we apply a current to the LED, it starts glowing or it starts emitting a light. Okay, so how it is going to do? So the electrons in the semiconductors are recombined with the electron hole pairs. So whenever we start applying a voltage across this LED, say suppose many of you know that it was on a 5 volts, 3 volts, 3.5 volts. Many options are there. Based upon the voltage level, it is emitting the intensity of the light. If the voltage is very less, it is emitting a very low intensity light. If the voltage is somewhat more than 5 volts or 5 volts, it is the intensity of the light is increased. Okay, so whenever current flows through this diode, it is combining the electrons and holes together, and then it is emitting those electron and holes, where the combination of this electron hole will produce a spark or a light signal. And the color of this light signal is going to be determined by the energy that is required for electrons to cross the band gap. That is the energy gap of any semiconductor. Okay, and this is called as the electroluminance. So this is LED image diagram. So there with the different colors, red color, green and blue. So it goes on like this. In the characteristics, we can see that the cathode current in a milliampere and a forward voltage. So whenever voltage is being applied, say suppose I'm applying a voltage of 1 voltage, then with this cathode, the cathode current is going to be incremented. So if I increase the voltage here, the current also increases in the cathode through the LED, and for a very low voltage, it is going to generate an infrared rays. Now, if I increase the voltage level to the one, a slight red LED is going to be generated around 2.5, I think, 2.5 volts, and it goes on. For 3 volts, around it is orange color, and for 4 or maximum 4, it is around blue color, and it goes on. So as the voltage is going to be applied, the current through the LED is also increasing in a milliamperes. Then there are different colors are generated through one LED. Even multiple color LEDs are there. In a single LED also we can generate multiple colors. Okay, this is about LED. And optocoupler also we have discussed, right? It is going to give an isolation between the circuit 1 and circuit 2. Okay, this is an example, and with an example what we have taken, one AC supply of 230 watts is connected to the Arduino controller, which is working on 5 volts on another side. Do you remember that? Hopefully. So some definitions are there. Just go through this definitions. So, okay. Now we go
Sir,
for, yes,
could you repeat optocoupler once again, sir?
optocoupler. Okay, no problem. So optocoupler is basically used for isolation purpose. What is isolation? Isolation is separation. Okay, separating the two parts. Why we are separating the two parts? So that we don't want any harmful effect of one part to the another part. So avoid that, to avoid that effect, we are giving an isolation between the two circuits. Okay. So in the previous class, we have discussed that by taking an example of Arduino microcontroller and motor with a 230 voltage AC supply. Okay. So whereas the pin number 1 and 2 were connected to the microcontroller, and pin number 3 and 4 are connected to the power supply or the motor with working with 230 volt AC supply. On the circuit 1, it was DC circuit. On the circuit 2, it was AC circuit, AC power supply. Now, in between this, we have used optocoupler. So, what is this optocoupler? It is going to provide isolation, a separation between the circuit 1 and circuit 2. What is this? What it contains? What the optocoupler contains? So basically, this optocoupler contains one LED, IR LED, infrared LED, and then one phototransistor. So phototransistor is equivalent to the photodiode, right? That already we have discussed. Photodiode, whereas a light falls upon the photodiode, it is going to generate a small amount of current. Likewise, the phototransistor is also there. Whenever a light falls upon this transistor, it is going to generate a small amount of current, which is going to control the second circuit. Okay, so this IR LED, infrared LED, is also an LED, but the input to this IR LED is 700 nanometer to 1100 millimeters of wavelength. It is going to generate that much of wavelength light, a light which cannot be visible. Okay, IR LED. Then, if at all anything happens in the 230 voltage supply, any harms like sparking or short circuiting, something, if anything goes wrong in the circuit 2 of 230 voltage power supply AC, that will not affect the circuit 1 where our microcontroller is connected. So this is what the function of optocoupler is going to be provided, right? Sayed, I think someone asked to repeat this optocoupler. Have you understood?
Yes, sir.
Okay, the person who has asked,
Yes, sir.
is that clear?
Yes, sir.
Okay, fine.
Yes,
Sir,
sir.
how does it work, sir?
Sorry.
How does it work, sir? Optocoupler?
See, in the right side, you in this figure, you can see one IC is there, no? PC817, PC187, right? Can you
Yes,
see?
sir.
Yeah, this is the IC where we can see, like in the previous class. Actually, I don't have that image right now. So what is happening here? On these two pins, the microcontroller is going to give signals to this PC1817 to switch on the motor. Okay. So this is I'm just roughing out here. So we have three blocks here. One is the 8051 microcontroller, which is working on 5 volts. Okay, this 8051 is going to give the signals to the optocoupler. The optocoupler is this PC817, which is having the 4 pins here. Pin 1 and pin 2 on the right side, pin 3 and 4 on the right side, left side and right side. Okay, so in this PC817, there are two components. One is IR LED and another one is phototransistor.
Excuse me, sir.
Yes, yes.
Sir, voice is breaking, sir. Unable to hear properly.
The voice is breaking.
Yeah, sir.
Okay. What about now? What about now?
Now it's clear, sir.
Okay, fine. So here on the left side we have 8051 microcontroller, which is controlling a programming part, which is working on 5 volts. This is the hardware. Okay, and on the right side we have 230 volt, say AC motor. We want to control this AC motor by the 8051 microcontroller. So somehow we do some programs and some connectivity between 8051 and 230 volts AC motor. Now our worry is, if at all something goes wrong in the 230 volt AC motor, that should not affect our 8051 microcontroller. So for that purpose, what I am placing optocoupler. I'm using optocoupler in between the 8051 and AC motor. What is this optocoupler is doing is, whenever microcontroller generates a signal, that is given to IR LED to switch on. If suppose if 8051 wants to switch on the AC motor, now this will send a signal. 8051 will send a signal to the optocoupler. A small amount of current voltage is going to be given to optocoupler. So basically here, first input signal is IR LED. Input signal is given to IR LED. Now whenever a current flows through this IR LED, that is going to generate a light signal. A light signal in the form of 700 nanometer to 1100 millimeters of wavelength, which is invisible, or it is a ray, X-rays or whatever we call, with the wavelength of 700 nanometers and 1100 millimeters. This is the range that this IR LED is going to generate wave light signal. Okay, do you know what is wavelength? It is intensity, not an intensity, it is the, what I can say,
Distance between the waves.
yeah, the signal, light signal will be there, no, that will be having a wavelength in a frequency, in a meters. Okay, so basically when you go for optical signals, then it is measured in a wavelength. Light signal is measured in a wavelength. So that light signal unit is wavelength here, and that light signal is having the energy of 700 nanometer to 1100 nanometer millimeters. So that is very small. So when that is going to be generated here, and when that signal falls upon the phototransistor, now again phototransistor is same like a photodiode. So whenever light signal falls upon this phototransistor, it is again going to generate a small amount of current. So that current is going to switch on, that is, it is applying this AC motor to turn on. Okay, so during this time, if at all something goes wrong into the AC motor, short circuit happens in the AC motor, say suppose like that. Okay, then what will happen? That will affect the phototransistor, correct? But the phototransistor is acting like a output here. Phototransistor is acting like a output here. Now it will not accept the input. So whatever goes wrong, there may be effect on this phototransistor. Because phototransistor is not going to affect IR LED, IR LED will be remaining safe. And because this optocoupler may damaged, the our microcontroller will remain as it is. There is no problem on 8051. Right. Is that okay?
Yes, sir.
Yes, sir.
Okay, fine. So then we go for BJT. What is BJT? Bipolar junction transistor. Okay, fine. This about this BJT will have a fresh class for this. We will not repeat the things in the next classes. Okay, and then I will provide this sheet, this document to you in the group. Fine. We'll close the session here.